I want you to imagine, just for a second, that you are driving down the highway. You're cruising at, say, 100 miles per hour.
Okay, pretty fast.
Right. And suddenly, your mechanic leans over from the passenger seat and says, hey, we need to swap out the engine.
Just right there on the highway.
Right there on the highway. But you can't pull over. You can't slow down. You have to completely rip out the old combustion engine, drop in a brand new electric one, and keep the wheels spinning the entire time.
I mean, that sounds literally impossible.
It does, right. But that is exactly what Europe's largest port is attempting to do, like right now as we speak.
Yeah, it's a phenomenal logistical and engineering tightrope walk. You're talking about Rotterdam, obviously.
Yeah, exactly.
They are currently racing to transition entirely from fossil fuels to renewables by the year 2030. And, they have to pull off this massive infrastructure overhaul without letting the lights flicker for their 1.3 million residents.
Yeah, which is insane. And to understand how they are actually pulling this off, we are doing a deep dive today into a highly detailed 2026 strategy guide by EtherMind.
Right, the new report.
Yeah, it focuses entirely on the AI energy transition happening in Rotterdam. So the mission of our deep dive today is to really figure out why artificial intelligence isn't just, some fancy optional software upgrade anymore. In this specific scenario, AI is the literal engine driving this massive 2.3 billion euro a year sector forward.
And the timing of this deep dive honestly couldn't be more relevant. I mean, today is March 12th, 2026.
Yeah.
So right now, literally as we're having this conversation, the AI for Energy Transition Europe Conference, the AIE 2026, is happening in Rotterdam.
Right now.
Right now. And this is hot on the heels of the EI Global AI Summit that just wrapped up in February. So the entire global energy sector has its eyes fixed on the city today. It's basically the absolute center of the universe for energy innovation right now.
Yeah, it really is. But before we get into the shiny new technology and how these algorithms are actually keeping the power grid alive, we really need to set the scene.
Yeah, definitely.
Because these energy firms aren't just operating in a technical challenge, right? They are operating inside this intense regulatory pressure cooker.
Absolutely.
Like, Rotterdam's Port Authority oversees more than 3,800 energy-related businesses.
Right.
We are talking about massive global giants operating there, like Shell and Uniper, alongside dozens of mid-cap utilities.
And the sheer scale of that operation brings us to the massive twist in the story here. Because as of January 2026, so just a couple of months ago, the new EU AI Act officially went into enforcement.
Right.
And the European Union did not mess around with this legislation. Under this new act, energy grid management is legally classified as high risk.
High risk. Which means the regulatory microscope is just dialed all the way in.
Precisely. If these companies are using AI to manage the grid, and they are found to be non-compliant with the new laws, the penalties are staggering. I mean, they are looking at fines of up to 6% of their global revenue.
Wait, hold on. Global revenue.
Yes.
Not just the revenue from their European divisions.
Global. Entirely global. For a multinational like Shell or BP, that is an existential threat. It's not a slap on the wrist. It is a number that completely wipes out quarterly profits.
Okay, let's unpack this, because 6% of global revenue is terrifying.
Yeah, it is.
But surely these massive tech-forward energy giants have been preparing for this for years, right? Like, they must have armies of compliance officers ready for this.
Well, what's fascinating here is just how unprepared the industry actually is. According to a 2025 McKinsey study referenced in the source material, 71% of European energy executives completely lack internal AI governance capabilities.
Wait, 71%?
71%. They are suddenly required by law to have entirely transparent AI decision-making. That means no black box algorithms. They need documented human oversight protocols. They need regular audits. They need rigorous bias testing to ensure the AI isn't unfairly prioritizing certain grids over others, like keeping the lights on in wealthy neighborhoods while browning out industrial zones. And the reality is, the vast majority of these leaders don't even know where to begin.
So it's like hiring a genius assistant to run your power grid, but you have to legally prove how they're making every single mathematical decision at lightning speed. Otherwise, you could just go bankrupt from fines.
That's a great way to put it.
But wait a minute, isn't the whole point of advanced machine learning that it inherently is a black box?
Yeah, usually.
Like, it processes millions of variables in a microsecond. How on earth do you force an algorithm to explain its math to a human auditor when it's operating at that speed?
And that is the exact paradox they are wrestling with. Because in a traditional deep learning model, you feed data in and an answer pops out. And honestly, even the developers don't entirely know the exact pathway the neural network took.
Right.
But under the EU AI Act, you cannot do that with critical infrastructure. You have to use what's called explainable AI, or XAI. These are AI models constrained by rule-based layers, or they use shadow models that log every single decision tree step.
Okay, so you are basically forcing that genius assistant to show their work on a chalkboard for every single math problem they solve.
Exactly. Every single
So
one.
if you can't map out their thought process perfectly, you could get hit with that fine. Which brings me to a really big question. If the stakes are a potential 6% global revenue fine, why take the risk at all?
Right. Why not just use humans?
Yeah, why hand the keys over to an algorithm in the first place?
Because the old ways of managing power simply don't work with renewable energy. Think about fossil fuels for a second. If you need more power on the grid, you just burn more coal or gas.
Yeah, you just turn a dial.
Exactly. It is a dispatchable, completely controllable resource.
Sure.
But you can't tell the wind to blow harder.
Yeah.
You can't ask the sun to shine brighter.
So you're dealing with a supply that is entirely at the mercy of the weather.
Exactly. Renewables are inherently intermittent. Now think about your own neighborhood. You come home at 6 p.m., you kick on the AC, the oven goes on, the TV is blaring.
Right.
That demand is happening whether the wind is blowing or not.
Yeah.
So when you're trying to balance that highly unpredictable supply with the real-time, minute-by-minute energy demands of 1.3 million people, human calculation is just too slow. Machine learning is literally the only tool capable of looking at the weather, looking at the grid demand, and constantly adjusting the flow of electricity in real time to keep the system from collapsing.
And the global numbers totally back that up. Like, according to the International Energy Agency in 2024, AI-optimized energy systems can actually reduce global emissions by 4% by 2030.
Which is huge.
It's a massive chunk of global carbon just erased by smarter math. But how exactly is the math doing that? Like, what is the actual mechanism?
Well, let's look at smart grid optimization as an example. By using AI for real-time demand forecasting, these companies are reducing peak load by 12 to 15%.
Okay, but how? Are they just, like, turning people's power off?
No. They are intelligently shifting the load. So the AI is communicating with smart thermostats, industrial cold storage, EV chargers.
Oh, I see.
Yeah. It knows that your electric vehicle doesn't need to be fully charged the second you plug it in at 6 p.m. It just needs to be ready by 7 a.m. when you leave for work.
Right.
So AI holds off on charging your car until maybe 2 a.m. when the wind is blowing hard and general grid demand is incredibly low. It smooths out those massive spikes in demand, which makes the whole grid operate up to 15% more efficiently.
And here's where it gets really interesting.
Hmm?
To do all this safely, the EtherMind guide mentions they use something called a digital twin.
Yes, the digital twins.
Which, at first glance, it sounds like playing one of those city-building video games, right?
Hmm.
But with actual billion-dollar public infrastructure.
That's a good starting point, but we really need to push that analogy further. It's not just a simulation you build on a laptop. A digital twin is a parallel virtual universe that is being fed live real-time telemetry data from the actual physical transformers, wind turbines, and substations out in the port.
Wait, so if a physical sensor on a transformer gets too hot in the real world, its digital twin starts blinking red in the simulation?
Precisely.
Wow.
And that allows engineers to digitally crash the power grid over and over again to test new integrations safely. If they want to see what happens when a massive solar farm suddenly gets covered by a cloud bank, they don't test it on the real grid. They run the simulation.
Right.
They can push the system to its absolute breaking point, figure out exactly how the AI will react, and not a single real citizen's lights go out.
It entirely removes the physical risk from the testing phase. That's brilliant. And then once they know the AI handles the simulation well, they deploy it to the physical equipment. And the AI takes over the maintenance too, right? Because through predictive maintenance, the AI monitors the microscopic vibrations and temperature fluctuations of a turbine and predicts when a part will fail weeks before it actually breaks. The source says they are cutting unplanned downtime by 35%.
Which isn't just a cost-saving measure, by the way. When a major piece of grid infrastructure fails unexpectedly, the power it was carrying has to instantly reroute, which can overload the next transformer and the next, causing a cascading blackout. Predictive maintenance prevents that entire domino effect.
Right. Now, it's easy to digitally crash a power grid in a simulation with zero consequences. But EtherMind actually had to deploy this on a live grid. The strategy guide provides a really compelling ground truth case study here.
Yeah, the mid-size utility.
Exactly. They worked with a mid-sized Rotterdam utility company that serves about 250,000 households, 250,000 homes.
And the utility was in serious trouble. Because of the exact problem we just talked about,
Yeah.
spikes in renewable energy integration, they were experiencing 8% grid losses. That means 8% of the power they generated was just vanishing due to inefficiencies before it ever reached a single home.
Which is incredibly expensive.
Uh,
But worse than that, they were having to do frequent load shedding. For anyone who hasn't experienced that, load shedding is when the utility deliberately shuts off power to certain areas to prevent the whole system from collapsing under a spike in demand or a drop in supply.
It is the absolute worst-case scenario for a utility provider. It furiously angers your customers, it damages equipment, and politically, it is just a nightmare.
Right. So EtherMind came in and deployed an AI-powered forecasting system. And this wasn't just reacting to the wind in the moment. The AI was predicting wind generation a full 48 hours ahead of time. I really want to dig into how it did that because it's obviously not just looking at a weather app on a smartphone.
No, it is ingesting terabytes of data. It pulls in satellite meteorological data, historic wind shear patterns for that specific coastline, and it maps all of that against the specific aerodynamic drag of the exact turbines they operate in the port.
That is wild. And once it knows exactly how much wind energy is coming 2 days from now, it optimizes their battery dispatch. So it calculates the minute-by-minute energy demands of those 250,000 homes, looks at the degradation curves of their massive grid batteries, and decides, do we store this incoming wind energy or do we push it out to the grid immediately?
And because it's doing that math thousands of times a second, the results are just staggering. Within just 4 months of deployment, their grid losses dropped by 6.2%.
Wow!
Their peak load management improved by 11%. And from a purely financial perspective, they saved 340,000 euros annually just in balancing costs, the money they usually have to spend at the last minute to buy emergency power when the wind dies down.
Plus, because of how the system was designed with those rule-based layers we talked about earlier, it had transparent decision logs, so they achieved full compliance with the EU AI Act. No fines, no regulatory existential crisis.
Right. And then we connect this to the bigger picture. The strategic business angle here is massive. This utility completely flipped the narrative. They took a terrifying regulatory compliance headache and turned it into a weapon.
How so?
They now actively market themselves to international partners as an AI-first utility. That specific branding, backed by proven compliance and efficiency, is a competitive edge that is literally winning them millions in new contracts. They aren't just surviving the transition, they are monetizing it.
Okay, I'm going to play devil's advocate here for a second.
Okay, go for it.
If the deployment only takes 4 to 8 months, and a mid-sized utility can see hundreds of thousands of euros in annual savings while avoiding an existential 6% global revenue fine, my question is, why isn't everyone doing this?
It's a fair question.
Right. If it's this good, why isn't every single one of Rotterdam's 3,800 energy businesses fully AI integrated today? There has to be a catch we're missing.
You're right to be skeptical, because there is a massive catch. It really comes down to 2 major roadblocks: data swamps and brain drains.
Okay, data swamps. Let's start there.
Right. A 2025 Deloitte statistic in the report reveals that 58% of Dutch enterprises still lack integrated data platforms.
Over half of them.
Yes. And AI is entirely dependent on data. Clean, structured data is the actual fuel for the AI engine. You can buy the most sophisticated machine learning algorithm on the planet, but if you feed it garbage data, it will just confidently make garbage decisions.
So what does a data swamp actually look like inside an energy company?
Well, it looks like a dozen different legacy software systems that do not talk to each other. The maintenance logs are on one server from 2008. The customer billing data is in a completely different cloud system. The real-time transformer telemetry is siloed somewhere else. If the AI cannot ingest all of that data into one unified platform, the engine stalls before you even get it on the highway.
So these companies have to clean their own house before they can even invite the AI inside. That makes sense. But even if they get their data perfectly structured, there is a massive human bottleneck. The local universities in the area, like Erasmus University and TU Delft, they are incredible research institutions. But combined, they are only producing about 300 AI-trained professionals every year.
And the local Rotterdam energy sector alone needs over 500 right now.
Just the energy sector.
Just energy. That doesn't even account for the banking sector, the healthcare sector, or the logistics companies that also want to hire those exact same 300 graduates.
Right. If you are a 22-year-old AI graduate from TU Delft, you are getting offers from massive global tech companies. The utility has to convince you that fixing the power grid is a cooler, more impactful problem to solve than working on the next big consumer app. There is just an acute skills gap.
Which raises an important question. If you are a utility company and you can't hire enough engineers to build a custom smart grid today, but the EU is breathing down your neck, what do you do?
Well, the guide says you find quick wins. You implement stopgaps that buy you time and capital while you build out your bigger infrastructure. And one of the most effective stopgaps they mention is customer engagement AI. Firms are deploying AI chatbots like the AetherBot to handle the front end of the business.
And that isn't just a simple FAQ bot. These bots are integrated into whatever data the company actually does have, so they can manage complex billing inquiries, provide 2,147 energy advice, and instantly process outage reporting.
And the ROI on that is immediate. Like, the guide notes that deploying these bots reduces customer support costs by 40%, while actually raising customer satisfaction scores.
Which is pretty rare for a chatbot.
Right. But think about it from the user's perspective. When your power goes out at 2 a.m., you don't want to wait on hold for an hour to speak to a human. You want to text a bot, have it instantly cross-reference the live digital twin, and text you back in 2 seconds saying, hey, we see the outage, a predictive maintenance crew is exactly 2 miles away, power will be restored in 14 minutes.
Right.
That is how you raise satisfaction.
Exactly. It captures immediate operational savings that can then be reinvested into solving those bigger data and infrastructure problems we talked about earlier. Because the reality is, the window for these local competitors is incredibly tight. We are talking about global majors operating in Rotterdam companies like BP, Equinor, and Ørsted. They have incredibly deep pockets, they have the talent, and they're already heavily experimenting with AI in their renewable operations.
The clock is ticking. The guide explicitly warns that local Rotterdam firms that secure the talent and structure their data now are the ones who will capture the regulatory trust and the investor capital. If you wait until 2027 to start figuring out your data integration, the global giants will have already eaten your market share.
And that is exactly why the AI Eat 2026 conference happening today is such a critical inflection point. The companies that can walk the floor of that conference today and prove they have a functioning, explainable AI strategy complete with EU compliance, they are securing their future. The ones who are still treating AI as an afterthought, just trying to bolt it onto their old 20th century business models, they are going to be regulated or outcompeted into irrelevance.
It's a fascinating landscape. To bring all of this together and summarize the core message we've unpacked today, adopting an AI-first energy strategy in Europe is no longer just about showing off cool predictive algorithms in a PowerPoint presentation.
Definitely not.
It is a fundamental survival requirement. It requires tearing down those legacy data silos. It requires aggressively investing in human training to fight the brain drain. And above all, it requires implementing rigorous, transparent compliance to survive the new EU AI Act.
Yep.
The companies in Rotterdam that are realizing this today are the ones actively winning the transition to renewables.
It is a massive paradigm shift. I mean, we are moving from seeing AI as an experimental IT tool to recognizing it as the core operational brain of the business. The energy grid of the future simply cannot exist without it.
I want to leave you with a lingering thought to mull over tonight. Later on, when the sun goes down and you walk into a dark room, you are going to reach out and flip a light switch. Or maybe you'll plug in your phone to charge.
Yeah.
When that power flows instantly into your device, I want you to wonder, is there a human sitting in a control room somewhere making sure that electricity is routed perfectly to your home? Or is an invisible AI operating on 48-hour-old wind predictions and split-second battery degradation calculations the only thing keeping your room bright? It's a wild thought.
It really is.
Thanks for joining us on this deep dive.